There are times when we want to prevent different executions of workflows from executing at the same time. Perhaps a previous execution overran over than it was scheduled to run, and you want to stop the next execution from overlapping, or maybe there's a sensitive API call that you want to protect, or perhaps there's a particular piece of data you want to protect from being accessed at the same time. That's where the exclusivity pattern comes in. So let's see this in operation. So let's take the first scenario. So here we may be on a schedule, and we're going to create a schedule trigger here, and we're going to say run this every second. Okay, so this workflow will run every second, and we're going to perform an activity, and we're going to simulate that with just a simple wait node. So we're going to wait for 5 seconds to do something, and we're also going to add a do nothing node at the end just to remind ourselves that we're finished. Finished. Okay, so we're going to every 1 second execute this particular workflow. It's going to do something which takes 5 seconds, and then it's going to finish. So instantly we got potentially a problem. This may be desired behavior, but often it's not. What we don't want to do is have multiple executions running at the same time. Let's see what this looks like. So if we activate this particular workflow now, let's close down these messages, have a look at the executions. We see now there's 5 running at any one given time. Oh, they finish, but there's still 5 running because one is finished, another one starts, and we've always got 5 of these running at any given time. So let's just stop that for a second, stop it from continuing. Go back to the editor. So that means that this activity is being overlapped, is being executed in parallel at least 5 times in this particular scenario. So how can 8-Kit help us prevent that from happening? So what we can do is we can add an 8-Kit node, and what we're going to do is ask 8-Kit for a lock. And we're going to give it a key, and this can be any string. It needs to be a unique string, and for now we're just going to call it test. This is a really useful piece of metadata that we can apply here. So this is exclusivity demo. So this basically tells us when we're doing some debugging that it's the exclusivity demo that was trying to acquire this lock and actually did acquire this lock. If you've got multiple workflows running in parallel, you may want to know which particular workflow acquired a lock on a given key, and so that's really useful. We can also specify an automated timeout. So in our example here that takes 5-6 seconds to run, you may want to put a 6-second timeout there so that we know that we always have that lock is being released every 6 seconds. But we're not going to do that, but it is something that you may want to think about doing, particularly with self-healing designs where you want to make sure that your architecture will recover from any mistakes or errors. So we're just going to acquire the lock test. If you cannot acquire the lock, you just want to finish. You don't want to continue. If you do acquire the lock, however, you want to complete the activity, and then you need to tell 8-Kit when you're finished. So what we're going to do is go back to 8-Kit. We're going to release a lock, and remember the name of the lock that we created was test. So that is now the protected version of the same workflow. Let's just save that before we reactivate it. I'm going to the executions. I'm just going to check the last time this ran was around 1931-32. Great. So when I reactivate this, I can come back and take a look at those. So what we'll see now is there are lots new versions of this running, lots new executions. Some are taking 5 seconds to run, some are taking very short amount of time to run. So that gives you an idea of exactly what's happening now. So we've got a few invocations going. Let's see what actually happens. So let's turn that off. And let's go back to when we reactivated the workflow. So as you'd expect, the first time we reactivated, we had a lock acquired. it actually did something. You can see from the ticks, we do something, and then when it's finished, it released a lock. That took 5 seconds to complete. 1 second after starting that workflow, another invocation came in, another execution started. It tried to acquire the lock, it could not acquire it, and it instantly bombed out straight to the end of the workflow. And that's exactly what we wanted. We wanted to protect this piece of code here, these nodes, from being executed. Only one execution was supposed to be able to do something at any one given time. And if we look here at the other executions, the next one came along, same thing happened, it bombed out, same thing, same thing, same thing. Now, the next invocation actually did manage to acquire the lock, and that's because the first execution that we executed had finished. And so the lock was released, we acquired it again, and then we went ahead and started processing. And the same pattern happens again. We have the next one failed, 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 and then we acquired the lock again and proceeded. And that is effectively the exclusivity pattern. But the example I've given you here is really based on a very wide global use of the pattern for actually restricting or having exclusivity on a complete workflow. There are times when you probably don't want to do that. You may want to have multiple versions of workflows running, but protect a very particular piece of data. So let's have a look at that. So in that case, what we're going to do now is simulate something else. We're going to kind of presume that we have some data that we've accessed from an API. So we get data to process. And that data undoubtedly will have some form of ID. And let's say that the ID here is 12345. So we're happy to process data, but I only want it to ever process this particular piece of data once and only once at any given time. So what I'm going to want to do now is change the lock. I want to change the lock so that I'm going to make my life easier by executing this step, by actually creating the key to the lock, which is very tightly bound to the data I wish to process. So in this case, I'm actually going to say here that the key is 12345. And that means that any workflow that tries to access the data with ID 12345 needs to acquire a lock before being able to do something. So I can call this 1,000 times with different data, and it will happily run in parallel, providing that we've got different IDs to process. Obviously, we have a lock here now with a particular ID, and so I've got to also release that particular ID as well. So in this case, let's just execute the step. The ID is there. We do something, we execute the step, we wait 5 seconds, and then I can actually just simply drag that ID into there. Okay, execute the step and release it. Okay, so that is now the same pattern, but bound to a much tighter piece of data, if you like, not just a full complete workflow, but an actual specific item of data. And obviously you can use composite keys here if you want to say that that's the order with ID 12345. Then that might be a nicer way of managing your locks as well. You'd obviously have to release the order-ID-12345 there if you wanted to use that technique, but it does mean that you can effectively limit things and name things however you want, use composite keys very easily just by creating the string that you need. And that is the exclusivity pattern.